Okay, I do have a question. Those two I should have said not to worry about. Okay. We're going to do that whole geometry section later. So, all right, guys. Real quick. Number one. Who's got that? I like it. So you just had 3 4s and 3 3s all multiplying, so it's a more concise way to say it. I didn't want to see the number. I don't want you to actually multiply this out. Only if I said simplify, or like the next thing says evaluate, those mean do all the operations. This, when I write exponents, that's kind of like me seeing how much work I have to do eventually. Eventually I got to multiply 4 3 times, I got to multiply 3 3 times. It's just kind of collecting my work. You guys with me? Okay. Number 2, the same idea. This will be 21. Good, because there's 4 21s multiplying, so a more concise way to say that is 21 to the 4th power. Cool. Of course, if you did that, that gets pretty big, pretty quick. Right? I like that. As you can tell, this was locally made. I didn't make this. 81s at the first. Now this, when people see this first, they're a little freaked out about it, but that first power is almost always there. It's kind of like an understood thing. In fact, I could write the number 81, because that's all this means. I have 181, so I have 181. I could write this as 1 times 81 to the first power. I could have all these understood ones. I don't want to write every number like that. So math people, we just said, we understand they're there. Let them go, right? So I don't need that, I don't need that, and I don't need that. That's just got 181. What's going to get freaky is when we start talking about 0 powers and negative powers. That's in our future. Right now, we're not going to worry about it. Something to look forward to.
81.
I like it, because 3 to the 4th would be, if you expand it, would be
9 times
3 times 3 times 3 times 3.
7. Yeah.
So you could actually do this.
9 times 7.
I love it. 9 times 9, and that's quick. Or you can do 3 times 3 is 9, times 3 is 27, times 3 is 81.
9 times 7.
So you guys probably went, that can't be right, it's the same thing. But, oh, this is a good one.
1.
I could put whatever I want to up here, really.
Yeah.
1 to any power is 1. If you multiply 1 by itself, how many times do you get 1? How are we doing so far? Is that cool? All right, good, good, good. 7. And let me say this also. If you have a question and you don't want to say anything, because everybody around you is like this, I got at least half of them are lying. If you ask the question, we'll be there here. For some reason, people want me to think everything's good. I have no idea why. My main purpose here is to help out if you have problems. Why would you want me to think everything's fine when it really isn't? So if you have a question and you don't want to hold people up, you're like everybody else understands. No, they don't. If you have a question, at least 8 other people have the same question. You would be their hero if you ask them. Does that make sense? Trust me, I've seen this happen. So 4 squared is a nice little dude. Good, 16, because that's 4 times 4.
1,000.
Yeah, 10 cubed. This is kind of cool. 10 to any power, that power tells you the number of zeros. That's a quick way. So 10 cubed is 1 with 3 zeros after. 10 times 10 is 100, times 1 more 10, 1,000. So 10 to the 27th power would be 1 with 27 zeros. Big ass number, but we don't care, it's easy. Right? Just give me some time to make some zeros. We're scared of the number 9, so we'll go to 10. I think we actually did this problem earlier. So you do this multiplication first. So everything else stays exactly the same. 6 times 4 is also known as 24.
8.
Cool. Okay. This one you almost can't go wrong because they put the 1 first that you have to do first, but you divide before you subtract. So 48 divided by 8, 6. 6 minus 2, 4. Let me say this real quick. If on the homework, if you have a problem like this and you just put 8 and you just put 4, I'm going to ask you to redo it because I don't know where that came from. You got to show me something. If there is one intermediate step that you could do like this step, I must see it, right? So you could have put 6 times 4 in the calculator. I would never know. But at least you yourself have to understand what the order of operations is. That's the part that I really want to force. Let's see. 12. And I was telling somebody earlier that was asking me about this problem. Order of operations tells you what to do first and so forth, but it also kind of tells you what to do last. What would I definitely do last here? Addition. So then that does kind of break this up into 2 parts. 2 times 5, 10. 4 times 6.
24. 34.
Sweet. Cool. So, let's see. 13. Exactly. So parentheses kind of act. Can't come in. Sure, they hope it's going to happen. Parentheses kind of elevate operations. Normally you would do addition last, but putting the parentheses around them suddenly makes them more important. They get done first. So this is parentheses, not just addition. That's why I do this first because it's parentheses. So 15 plus 10?
25.
25.
5.
Divided by 5. I love it. Cool. Let's see. 14, sort of the same idea. Yeah. So you do in here first. Okay, so this 16 divided by is still there. I'm replacing this with what it is. And then 16 divided by 4?
4.
Now here, 15 I think might be the one that kind of jarred us a little bit when we saw it. We're like, all right, this is whoa. What are you definitely going to do last here?
Division.
Careful. When you see a big bar, you do the top, you do the bottom, and then you divide the 2. Now the bottom, is there anything to do down here? Now if they would have had like a +1, I would do the top, I would do the bottom, and then I would divide those numbers, right? We didn't have that, so now I just got to do the top. So the last thing I do always with this kind of problem is divide. Cool. So what do you got on the top? What do you have to do on the top first?
Parentheses.
Good. So I get 5 times 6 minus 2 is 4. And do you see how the 5 something plus 7 divided by 3, that all 5 something plus 7 divided by 3 is all still there. And I know I keep making that point, but this is a really simple thing that will save so many of you from silly mistakes. Just recopy and just change the one thing you're changing. So here, the next thing I do is multiplication, so that plus 7 and that 3 is still there. I'm just going to replace 5 times 4 with 20. Good, so I still got to finish the top.
9.
9. Is that cool? Yeah. Okay. So in general, here's something else. If I'm going too fast, slow me down. If I'm going too slow, deal with it. Please slow me down if I'm going too fast, because if I don't hear anything, I have a tendency to accelerate a little bit. So you got to put the brakes on if you need to. All right. Where are we at? 16. What's up? A little shaky on 30 minus. Anybody tell me what two things am I definitely going to do last? Yeah, that subtraction
Outside.
and that addition. I like it. What am I definitely going to attack first? Beautiful. So inside here. So this 30 minus is still here. This plus 2 times 3 is still there. I'm rewriting stuff in here. What do I do first in there?
8 minus 5. By 5.
You have an 8 minus 5 in the parentheses. Let me go ahead. Can I do this also? Is
Yes, you can.
that all right?
Yeah.
16 plus
3.
3. Yes, sir.
I'm sorry, I'm trying to backtrack here.
Yeah.
But for 15, and how you had 20 plus 7, I did 20 divided by 3 because I thought you did the division first.
So, if
But
I
you said you
rewrote,
do everything on top.
that's a good question. If I rewrote this in a straight line, this would look like this. Because the top is understood to be its own thing, and the bottom is understood to be its own thing. You with me? So there's an understood parentheses when I have this big division bar. So that means finish the top, finish the bottom, divide last here. Because if you look at it like this, that division would be last, right? You have to do that parentheses first. Does that make sense? So that big bar kind of throws us off. What do I do next here?
16 plus 3.
Cool. So inside there. Are we all cool with this? 16 plus 3 is
19.
minus 6?
13.
13.
6.
I like it. So you can do that 6 there? Good. So I get 30 minus 13 plus 6. I took those brackets away because there's nothing left inside to do. So they don't need to be there. Negative times 13 is minus 13. Now, do I do 13 plus 6 is 19?
No.
No.
No, Jeff. Tell. I like that. So, as it comes, 30 minus 13,
17.
17 plus 6,
23.
23. Sweet. So a lot of people were getting that number as I was walking around. That's good. And I got one last one I'm worried about. The area problem and the number 20 problem, there's actually a whole geometry section later, so I'm not really worried about those at the moment.
What's the answer?
Number nothing, the area problem is 144 square meters.
Uh-huh.
And number 20, I don't know, I have to think about it.
It's no.
Oh, it's 72 times 72
5,184.
divided by 1,200, so whatever the hell that is. I'm not going to try it in my head. I can do a lot in my head. Just not that much. Actually, now I want to do it. Well, I'll let it go. That's right. So 17. This looks a lot like the one we just did. In fact, it almost is exactly the same. All right. So again, it's really starts off the exact same way that this one did. It's got this big piece in the middle that I have to do. So then what do I get here?
25.
Careful now. 5 squared is
25
25.
plus
4.
4 times 2.
6. 12.
I like it. Cool. All right. Because you definitely would multiply before you add, so you can go ahead and do that multiplication. That's okay. It's not going to change anything. What can I still do in here?
50 minus 9.
The biggest mistake I saw here was everybody was doing 29 times 2. So if you did that, you're not the only one. But every time you look at it, you have to look at it fresh. I think we all say, okay, I already did order operations now. I guess I'm done with order operations. I can just, no, every single step it's true. So I don't add first, I multiply first. So it'll be 25 plus
8.
8. So I get 50 minus
25. Oh.
25 plus 2.
33. Yeah, because 25 plus 8 is 33.
And now 50 minus 33
Good. 50 minus 33. 17
plus 12.
plus 12. 29.
That's what I did.
So I saw a lot of 29s too, which is good. Because that was the right answer. All right, so I'll tell you what I'm going to do. I'm going to lecture just a little bit out of 1-8, and then I'm going to let us out of here. It's a tiny bit early. Yes, ma'am? That, now if you already have your learning results, your learning style results, you can go ahead and give them to me as you leave. They're not due till Tuesday. So if you haven't done it yet, and you haven't filled out the survey yet that's on my website,
We need to print out the result.
if you got the syllabus, it's on the syllabus. Waller, yes. Wall with the E on it.
Or do you want just all of them?
Sorry.
I thought we were just going to take notes for the lectures.
Does anybody else having trouble with the survey that tried it?
I'm going to sit next to you.
So, if you need to, write your answers down and give them to me, because then I can just put them in for you. Because what I get a spreadsheet at the end, so if you just give me, I can put the data in. If you have more trouble. Wait, guys, wait. Second.
Today, I didn't know you wanted to.
Oh yeah, exactly. Everything I gave out the first.
Get to all the lectures. But next class, I'll be sure to be reviewing some of it.
Thank you.
All right.
You did 20.
Oh, shoot.
Yeah.
It's asking us to find the area, right? And then once you find the area, you find the difference, and if it doesn't match,
Right.
That problem, that's
I know.
what you want to do.
Oh,
That's what you were saying.
Is page 94?
the only homework 34
The test.
Or something. No,
That
I
was
don't
it.
remember.
That was it.
Which one to review?
Yeah, we give a date. Now, if you get say if you get this homework today, then we'll do it on Thursday next week.
Okay,
All right.
I will follow.
All right, guys. Here we go. So I'm going to let you a little bit out 1-8. Let us out here a little early. The biggest thing that shows up in your math career as you're going through middle school and then high school is when they first introduce variables. Right? And that's when everybody goes, what the hell? Why are you putting letters in my math? Right? But the whole problem is, in reality, we very often have things that we don't know that we still have to work with anyway. So if I only had some money, I could put it in here and make this much percentage rate, and then would I have enough money? Well, you have to have a placeholder there to kind of set something up. And then you can start throwing, well, if I had $10,000, if I had $20,000, and you can put them in there and see how much money you'd have at the end. You kind of with me. You can even set up an equation and say, equals this much money, and work out what you have to have in the first place. That's what algebra does for us. It gives us a thing to put in place of what we don't know, so we can still work with it as if we knew it. So if I said, add a number to 7, for example, how could you write that?
X plus 7.
I love it. So math people are always all about writing things in a more efficient way. Right? We don't want to write a bunch of words to describe something. We want a symbol. Symbol that means add, a symbol that means a number, and then 7 already has its own symbol, so he's all right. So far, so good? All right. So now, I could put whatever I want to in here and figure out what it is. So let me give you a different example. What if you're working, what's minimum wage nowadays? It was $3.25 my first job. I'm sure some of you guys would probably beat me with that, but what is minimum wage nowadays?
8.
Let's say 8. Let's say you make $9 an hour. Let's give you a raise. You have no idea how many hours you're going to work next week. So, here's the funny thing about algebra. You can answer this question. Even though I just told you, you have no idea how many hours you're going to work next week. So how many hours are you going to work next week? I love it. So algebra gives us an answer to a question we don't even know yet. It gives us a thing that we can work with. So I'm going to work X hours next week. So how much money am I going to make?
We don't know.
Don't bring taxes into it, because then it's going to make the equation a little bit harder. Let's just say you get all your taxes back because you're not working enough hours, but right. So how much money will you make?
Hours times X.
I like it, because if I worked 5 hours, you would make 9 times 5, $45. If I work 10 hours, you would make 9 times 10, $90. But you're working X hours, it's the same thing. Math doesn't care. X is a number. It's a number I don't know yet, but it's a number. So anything you would do with a number, you're going to do with that X the same way. So if it was 5, you multiply. If it was 10, you multiply. But it's X, you still multiply. So that is an expression that tells me my salary for next, my income for next week. Even before I know how many hours I'm going to work. So now if next week they call up and say you're going to work 7 hours next week, now I can say, oh, X is 7. So I plug a 7 in for X, and I get $63 next week, right? How we doing? Now obviously, when you first start working with this, the equations we're looking at are pretty simple. So a lot of times you're still saying, well, this is still adding crap I don't need. I could do this without a freaking variable. But the minute I start putting some more things into my equation, then variables become really useful. I can't do all this in my head. So if I said, what do you add to 7 to get 11? 4. So I don't need to be able to set up this equation. What do you add to 7 to get 11? So you can read that in English. It's crazy. All right, so math equations are sentences. I told you it's a foreign language. I don't need to do that. You told me the answer without it. But if I said double a number and then add half that number and you get 7 less than that number, there ain't no damn way you're going to keep all that crap in your head first and then start working and keep it all. No. Algebra lets us set it up, even though the thing we're working with, we don't know it. It gives us a way to set it up. You guys kind of with me? Obviously, I'm trying to sell you on this idea. And I don't have to sell it too hard because it's freaking useful on its own. Okay. We're not to the point where we're going to solve equations yet. We're just to this point right here. They're going to give you problems like this. This should maybe look familiar. Evaluate. Stay with me. Yeah, this is what I call plug and chug. All right. You plug that stuff in, chug the answer out. All right. So it's one step away from what we were doing back in 1.7. This is still an order operations problem. I just don't know what each of these are until they tell me. So now I take anywhere I see an X, I'm going to put 3. Minus twice negative 4. So see how I put it in parentheses? If you just put it in like this, what does it look like I'm doing? But what's the rule say I should do there? Oh shit, so I better put it in parentheses so I still know I have to multiply. All right, so it's still 3 minus twice something plus 5 squared, 11. And now it's just like a problem from the last section. So the very first thing you do with variables is to get used to just plugging stuff in. So for example, my statistics class. Statistics, of course, has its own levels of difficulty. But one thing they have to realize is there's going to be equations, and they just have to figure out what numbers to plug in to the equations on one level. Now, we have some Greek letters in there, and the equations are a little big, but it's the same stupid idea. Figure out what number to put there, put it there, put it there, put it, and then just work it out. So this idea holds throughout all of mathematics. This idea. It just gets harder and harder and harder stuff. You still just plug stuff in. So what are you going to do first here? Yeah, you can do a couple things here. What's negative 2 times negative 4? So it should be plus 8. Now another way to look at that is that's 3 minus, what's twice negative 4? Negative 8. What's 3 minus negative 8? Those two negatives cancel. So there's two ways to look at it. Personally, I look at it like negative 2 times negative 4. It's positive 8. Bam. Those two negatives will cancel. Make a plus. Plus, what's this?
25.
Yeah, good. So you get 11 plus 25, 36. Cool. Okay, so you have a bunch of problems like that where they have X's and Y's and Z's and W's and A's and B's and whatever, and then they got to tell you what each one is. So it shouldn't be that evil, as long as you know your order operations. But then they're going to have problems like the sum of 3 and a number, or let's do the product of a number and 12. How would you write that in Mathish? I love it. You could do a number times 12, and I can't really fault you for that. But in general mathematics, we put the coefficient, the number first, and the variable second. So you could write that as 12x. Either way. Go for this way. That's convention. The one thing there's one extra little thing that's a little evil in this section. Let me see. We already talked about, for example, how would you do the quotient of 11 and a number?
11 over 8.
Careful now. So what's got to come first? 11. So the quotient of 11, quotient means divide, and a number would be x, or y, or w, or your favorite Greek letter, Russian letter, happy face, I don't care. Any symbol that represents a number. So normally we just use x if that's all we got to worry about. Right? Okay, cool. The one that's evil is this. And let me actually do this first. Can anybody tell me what is 5 less than 12?
7.
What did you actually do in your head? See, so I said, what's 5 less than 12? You did 12 minus 5. You see what I'm saying? So it's just English here is the evil one. Math is just coming in, hey. But so if I said 5 less than a number, the mistake is to do 5 minus x. That's wrong. 5 less than 12 was 12 minus 5. So 5 less than a number is x minus 5. That's evil. Well, why? When I said what's 5 less than 12, why did you do 12 minus 5? Because that's what we understand less than to mean. Right? Now, other words I use for subtraction would be what's 12 decreased by 5? That's 12 minus 5. That's exactly the same order. Are you with me? The only phrase that's evil is that phrase less than. 7 less than 8 is 8 minus 7. You don't say negative 1. That one kid's 8 years old. He's 7 years younger. Oh, he's negative years? What? No. You do 8 minus 7. You don't do 7 minus 8. He's not born yet. Pop. He's out of existence. That's freaky. All right. I better adhere to my... It's only 5 minutes, but it's still a little early. So next time we'll get back into section 1.8 and then into chapter 2. Cool. Oh, and I completely forgot. On Tuesday, we'll also do the little tour. I was going to do that today, but then I totally forgot. So the tour of campus on Tuesday. Exactly. You do the review, and then 1.7, and they're due officially a week from today. Yeah.